So, today it will be the next part of this chapter, hydrogen. Okay, last class I have discussed about the method, that is synthetic resin method to soft water, to make the hard water to soft. Okay. Now, today I will discuss the left one, that is Calgon method. It is the third one to make soft water from hard water. So, the name of the Calgon is that sodium hexametaphosphate. The name, it is a chemical compound, it is sodium hexametaphosphate. Sodium hexametaphosphate, and the formula of it is that NaPO3 whole 6, NaPO3 whole 6. Now, if we break the structure, it becomes ultimately Na2 Na4 PO3 whole 6, that is Na2 Na4 PO3 whole 6. So, it is a complex compound. Okay, this is the cationic part and this is the anionic part. Now, so the Calgon method, it is sodium hexametaphosphate and the formula is NaPO3 whole 6, and the breaking and the detailed formula is that is Na2 Na4 PO3 whole 6. Now, when we representing the formula again, just recap from the earlier concept, it was Na2Z, that is Na2L2 Si2 O8, again it was Na2Z. Here also we can make a generalization of Na2X. Okay. So, when a hard cations, that is calcium, magnesium is there, and if we pass it through the Calgon, then it produces, it exchanges the Na2 plus to the calcium plus. So, this is the Calgon method of removing the calcium or magnesium. Here in NaPO3 whole 6, the Calgon is a polymer of sodium hexametaphosphate, and the N, NaPO3 whole 6, its whole N, and it is where N equal to more than 1000, greater or equal to 1000. So, it is a large molecular mass. Now, what is the reaction? Just make a reaction, that is Ditipriya today discussion on the Calgon method of removal of hard water to make soft water. Okay. So, Na2 Na4 PO3 whole 6 plus Ca2 plus. So, it will produce Ca Na4 PO3 whole 6 plus 2 Na plus. It will be dissolved in the solution, that is in water. Okay. So, in this way you can exchange the cations, that is calcium and magnesium, from the solution. Next one, coming to the advantage. So, by this way the total separation, that is the preparation of soft water by hard water, was completed. One was temporary hardness, permanent hardness, 3 method. One is washing soda, then resin, resin there were two parts, and third one was Calgon method. Next one is the advantages of hard water. What are the advantage of hard water? Now the advantage of hard water is that advantage of hard water. First of all, the minerals, that means calcium, magnesium, is to some extent is useful to us for our body growth. So, if we exchange this, then it will no longer be useful for the body. Okay. This is one of the bad effects of this. Next one, as hard water checks the poisoning of water by lead pipes. How? Hard water checks the poisoning of water by lead pipes, because lead is dissolving in water, but if the presence of calcium and magnesium is there, then it is produces the calcium sulfate is present, some amount of calcium sulfate is present, then it reacts with the lead pipe, CaSO4 is present plus lead, it produces a layer of lead sulfate which is insoluble. So, the coating there becomes a coating. So, it is no longer be harmful. Next one is that as it is hard in nature, it is used for the preparation of the beverages, and because it is the presence of hard water, that means the presence of cations and anions make it tasty. Calcium and magnesium salt present in a small amount, okay, in hard water, and are very essential for the growth of our body. Okay. So, these are the important. So, first one was the importance to our body parts. Next one, the lead poisoning is to somehow decreased by use of the hard water, and third one, that is it is used to make the beverages. Okay. Because these are tastier, because the soft water is not tastier. When we take the mineral water, you can taste it, and in place of hard water it is more tastier. So, hard water is used for the beverages. So, these three are the important applications of hard water. What are the synthetic detergents? The soap is a large molecular mass having a hydrocarbon part and a carboxylic acid part. Now, it is called the long chain hydrocarbon, that is the long chain fatty acid, the sodium and potassium salt of long chain fatty acid. What is so? It is the sodium or potassium salt of long chain fatty acid. Fatty acid. What are the fatty acids? These are stearic acid. These are stearic acid, palmitic acid, etc. Stearic acid and palmitic acid, etc. This is so. Now, what is detergents? Now, detergents are, because we know that the scum is formed when soap reacts with hard water, but if the synthetic detergents is used, then it produces later when it comes contact also with the hard water and soft water. Now, the synthetic detergents are the compounds, that is lauryl sulfate. It is a composition of the shampoos, and also the sodium dodecyl benzene sulfonate. So, lauryl sulfate and dodecyl benzene sulfonate, these are the compositions used to make the synthetic detergents. Okay, so what are the synthetic detergents? It is the alkyl hydrogen sulfonate of long chain alcohol or alkyl benzene sulfonate. So, what is the detergents? So, next point is the detergents. What is detergents? It is the salt of alkyl hydrogen sulfonate. Alkyl hydrogen sulfonate or of long chain alcohol or alkyl benzene sulfonate or alcohol or long chain benzene sulfonate. Examples: L'Oreal, sodium lauryl sulfate, dodecyl, dodecyl benzene sulfonate, dodecyl benzene sulfonate. This is the formula of benzene lauryl sulfate, and SO3Na. This is the formula for benzene dodecyl sulfate. Okay. So, this is soap. Soap is the sodium salt of long range fatty acid, that is stearic acid and palmitic acid, and detergent is the salt of alkyl benzene sulfonate or alcohol or long chain benzene sulfonate. This is detergents: sodium lauryl sulfate, sodium dodecyl benzene sulfonate. These are the examples of the detergents. Okay. Now, just write down one problem. Write down one problem regarding to the hardness. One liter of a sample of hard water contains 1 liter of a sample of hard water contains 1.62 gram of 1.62 gram of calcium hydrogen carbonate CaHCO3 whole 2. Can you tell me that what type of hardness is this? Anyone? Can you tell me that what type of carbon hardness is this, temporary or permanent? What amount of lime is needed to remove hardness of what amount of calcium hydroxide is needed to free 10 to the power 6 liters of such sample. Liters of such sample. Can you tell me? Temporary hardness. Very good answer, Jhilam. Okay. So, 1 liter of a sample of hard water contains 1.62 gram of calcium bicarbonate. Now, first of all, you have to know about the atomic mass of that constituent, because you have to calculate the molecular mass of that. Okay. So, first of all, calcium hydrogen carbonate. Calcium hydrogen carbonate is present in 1 liter, 1.62 gram. In 10 to the power 6 liter, it is 1.62 into 10 to the power 6 gram. This amount of calcium bicarbonate is present. Now, just write down the reaction I have written earlier, CO3 whole twice plus calcium hydroxide, it will produce calcium carbonate plus H2O. Now, these are equimolar. Okay, this is not calcium hydroxide, it is lime. It is lime. So, the formula will be CaO. CaO producing calcium carbonate and water. Now, this is the balance form, CaCO3, twice CaCO3, hydrogen 2 and 1. Yes, this is balance. So, 1 mole of calcium bicarbonate reacts with 1 mole of the lime. So, here equimolar, no, here in the question it is lime is given. It is lime is given, but there you can take it with calcium hydroxide also, because in the books their calcium hydroxide is also there, but as here the lime is given, so we have to take it with lime, because we have to calculate it by the molecular mass of CaO. If we add hydrogen, then it will be somehow different. Okay. So, next calculate the molecular mass of both the constituent, that is calcium bicarbonate. So, calcium 40 plus 1, here 12, 13 and 16, 13 and 48, 161, 2, that is 122, that is 162 gram. 1 mole of calcium bicarbonate, it is equal to 162 gram, and CaO, it is 40 plus 16, that is of 56 gram. Now, 162 gram bicarbonate reacts with 56 gram of CaO. Here the present amount is 1.62 into 10 to the power 6 gram. Now, just take the ratio to make answer, that is for 162 gram bicarbonate, 56 gram CaO needed. For 1.62 into 10 to the power 6 gram bicarbonate, it is 56 divided by 162 into 1.62 into 10 to the power 6. It will be 10 to the power 4, then it will be cancels out. So, 56 into 10 to the power 4 gram. Okay. So, this is the required amount. You cannot see the lower half. it is 56 into 10 to the power 4 gram. If we convert it to kg, then it will be 560 kg of lime is needed. Clear? Okay. Now, tell me one product, that is what happens when calcium carbide reacts with water. What happens when calcium carbide reacts with water? What happens? What is the product? What is the product? Yes, very good answer. No, calcium hydroxide is correct, but not carbon dioxide. It is the preparation of acetylene, C2H2. It is the preparation of acetylene. It is used to make the oxyacetylene flame, which is used for welding, that is the gas welding. Another one example, when calcium phosphide reacts with water, what will happen? Calcium phosphide when reacts with water, what will happen? When calcium phosphide reacts with water, what will happen? Same type of reaction, but here a gas will be formed. What is the gas? It is phosphine, PH3, and another one, that is hydroxide, calcium hydroxide plus phosphine. When SiCl4 is hydrolyzed, very important reaction. When SiCl4 is hydrolyzed, this reaction will come and also in the group 614 also, SiCl4. When silicon tetrachloride is hydrolyzed, then what is the product? It is the production of SiO2 plus HCl. So, up to this today only. Next day I will start about the next composition up to the water is completed. Next it will be the hydrogen peroxide. Its property of hydrogen peroxide will be discussed on the next class. Okay. So, bye everyone.